Hey everyone! In this video we will show you about our college project some time ago, which is a prototype automatic sliding door in a workshop, where in this project maybe it can inspire you. Let's watch it together. First, this is the 3D illustration part for building design. This workshop will be a collaboration of two fields of work: woodworking for furniture production equipped with automation technology. Let's explore the inside of this room. We have several tools to support work activities such as drills, impact drivers, routers, jigsaws, miter saw, belt sanders, welding machines and table saws. Several popular branded tools are available in this space. In front of the glass doors, you can see the property in this room. There is also a computer desk. Well, here one of our team of workers can perform many tasks using computers such as for design, video editing, simulation, or other purposes. In addition, we also build on top of our workshops, for a cafe that maybe we and other people can gather or have a discussion here. Okay, this is an illustration of how the design of the door drive mechanical system is applied. In the motion mechanism of this automatic door, the drive system that works consists of several components as follows. Two sensor components for outdoor and indoor, two DC motors for a pair of rack and pinion gears, one linear shaft, two hangers, two pairs of limit switches and a floor-mounted guide rail. Let's try to focus on this drive system on the component parts of the rack and pinion drive. In this project, the rack is applied horizontally. Then the rack experiences two forces due to the movement of the mass. A force created due to the moved mass acting against the coefficient of friction of the guide rails, plus a force that results from accelerating the mass. In addition, if the application involves any external pressing forces, those are included in the tangential force calculation. Then if written in the mathematical formula, the tangential force on the rack is the result of the multiplying of the total mass, the gravitational constant, the guide friction coefficient, plus the total mass multiplied by the maximum acceleration of the system and, then added by another external force. If you don't understand about tangential force, you can't look from this picture. Well, it is a force that is perpendicular to the centrifugal or centripetal force, or it is said to be influenced by both. Then what about the torque and rotation speed? First, the torque on the pinion is simply the tangential force or the force on the rack divided by the pinion radius as follows. Remember to divide the pinion diameter by 2 to get the radius, and by 1000 to convert from to m or by 12 to convert from inches to feet. Then, to determine the maximum rotational speed of the pinion, simply divide the maximum linear speed of the application by the pinion circumference. Calculate it like the formula for the circumference of the circle. So, remember to convert from millimeters to meters, and convert from seconds to minutes. Then we can get the equation for determining the maximum rotational speed like this. This equation is sometimes simplified as followings. Furthermore, this is part of the circuit simulation. We are using the Proteus software. Two ultrasonic components that work like a sensor to obtain information from outside and inside the room. Then any object that blocks the trigger signal will be reflected back towards the receiving signal. The data information from the two ultrasonic sensors will be forwarded and processed by Arduino Uno, as we know it acts like the brain that regulates a system. So, after the object information is processed, it will send a signal to other devices. The L298N motor driver is a DC motor driver module that is most widely used or used in the world of electronics, which functions to control the speed and direction of the DC motor rotation. The chip inside uses the L298 IC, which is an H-bridge type IC. It is able to control inductive loads such as relays, solenoids, DC motors and stepper motors. To facilitate the interface between the user and the system, we use a 16x2 LCD along with the I2C driver module to save on the use of existing pins. In this case, the data we display is the motor speed variant data obtained from the potentiometer adjustment. Two DC motors connected to a set of gears act as components to drive the door. For that, we configure the control with the motor driver for easy control of the speed and direction of rotation. Then one potentiometer functions to regulate the speed of the motor connected to the analog pin on the Arduino, while the other potentiometer functions as a PID set point tuning, which is a conventional control method to get a better system response. To make it easier to understand this, let's try to observe the real simulation. Okay, watch carefully. You see the green LED is on as a standby indicator, then our hand is assumed to be a moving object with such a distance. And you see the red LED lights up to replace the green LED, which indicates the door must be opened through the reaction of the roll of a DC motor that rotates clockwise. Then we can give any delay time we want through the Arduino program. And the DC motor rotates counterclockwise to close the door again along with the standby indicator. So until this system runs. Easy enough, right? Next, let's take a look at the implementation.